I'd like to welcome you to the next video in the series. In this series, we're assembling an MSI 8080 CP-A front panel kit. We've been through all of the components up to this point, and it's time to mount some switches. So let's dive in and get some switches mounted. So we're down to the home stretch here, which is the switches. There's a lot to discuss here. I've removed the packaging from the switches. I've sorted them. There's two types of basic switch. There's a few full toggle. Hopefully this is on camera. That is either in one position or the other. There are momentary contact, which you can click one way, it returns back to center. You can click the other way, it returns back to center. So there's two basic types of switches here. There is the power switch with the power rocker. There's a pure toggle again. It's either on or off. Of course, we have the power down here and we have the momentary here. Momentary being the ones that return to center automatically. Here, and then all of these over here are toggle. You can install these in an octal format where it could be red, blue, red, blue, red, blue, I believe, or in hex where it's 4 red, 4 blue, 4 red, 4 blue, 4 red. I install them in hex. I think in hex it's easier to work in. That's kind of up to you, the order you want to install them in. So it talks about here, I think what we just hit was, boy, if I can get this page to agree here, I can get it to do everything but what I want it to. There's a power switch that we talked about here. There's 5 momentary contact. They're sitting here. They return to center. There's a 16-2 position, no spring return paddle. It mentions in here installing a temporary S100 connector to ensure proper spacing. I happen to have one sitting here. You may or may not have an extra one. That's an S100 connector. If you've bought an EXP22 motherboard, it'll be different than this one. This just happens to be one that I have here. I'm going to go ahead and put it on just because they call for it, and it helps a bit with spacing. This is somewhat tight to do, but it's on. That just helps ensure proper spacing. In your package will have been this right here. This is the switch support bracket and the screws for it. I can get it to unwrap here. This is a reproduction part. It was meticulously measured from an original and reproduced. And it's just a very nice sheet metal part. The bend radiuses, the hole diameters, all that stuff are identical to the original. And it mounts down here on the board like so. This kind of bend under sweep sweeps out, as you can see it here, points down. All of these drill holes are not tapped. They are just holes in the sheet metal. You'll have a little bag of hardware here. There's 2 different sizes of screws in this. Let me see if I can get it open. These poly bags in my fingers are always painfully difficult to deal with. I just can never quite get them open. It's always very frustrating when the little bags just won't agree with me. I'm just gonna, I think I'll dump these out over here in this corner and hope they don't roll away. There will be 2 with a larger head, and the rest will be this smaller head. And hopefully you can see that. 2 of the larger and a number of the smaller ones. You could probably see these are slotted screws, but don't be tempted to use a slotted screwdriver to drive these in. It does not work. You really need a proper nut driver. And that is the wrong nut driver. That's the nut driver I need. This is an SAE nut driver, 1/4 inch. It is not a metric nut driver. You can attempt this with a metric, but it really does not work well. Let me pull out a different nut driver and put the wrong one away. I just grabbed the wrong 2 out of here. I'm using a set of Husky nut drivers. They're SAEs, it says down here. And they're just, it's a nice tool for the price. And it's got this little carry handle to keep them organized. So we have the 1/4 inch nut driver here for those 2 big screws. And we have a 3/16 inch nut driver for the smaller ones. Well, I'm calling them nut drivers. Technically, that's what they are, but we're going to drive screws with them. And it's a perfect fit on there. Because no threads have been cut in this metal yet, it takes a bit of work to actually get the screw in because it's got to cut threads into the aluminum. So that's why with a regular flat screwdriver, it's really difficult to get these in the first time. And you end up with the screwdriver sliding off. And if you hit the board, you make a mess and those kind of things. I really recommend you find nut drivers, a 3/16 and a 1/4 inch. I've said it a couple times, they're SAE. I'm going to mount the switch support bracket. I'm going to start on one side. I've got one of the larger 1/4 inch screws. I'm going to get it through the board here. I'm going to get the 1/4 inch nut driver onto it. And that screw goes into one of these U-bends. And I can feel it cutting threads. I'm not going to tighten it all the way. I'm going to pull out the other. And I'm going to do my best to start it. Even with the nut driver, I find this pretty fiddly. I have very large hands. It makes this kind of stuff challenging. That one's really tight. And now I'm just going to go ahead and turn these down. Get good engagement with the nut driver. And pull it up tight. It doesn't need to be super high torque on it. It just needs to be a good firm grip. You want the screw to actually be square as it turns in. Yeah, this one's being a little more difficult. It is grabbed. We have the support bracket in place. Another comment here is I've soldered the ribbon cable in place already. We did it in a previous video. It's difficult with all the switches to get under there and solder that in. And the cable itself came with some foam to protect the pins. And I've put the foam back over the pins here to protect them while I work. Another comment I'll make about nut drivers is this. Of course, you can back these screws out. As I've done, that screw's completely backed out. If you need to back it out, when you go to reinsert it, drop it in place, get the nut driver and turn it backwards. And hopefully you heard that pop. There it was again. That pop is that screw dropping into the threads in the sheet metal that we cut the first time we put the screw in. By spinning backwards, until it engages with the original thread, you feel the pop and you hear it drop in. You're not cutting new threads into the sheet metal. If you put these in and out and just start them in a random location, you will eventually tear the hole up that they're screwing into and the screw will no longer engage. This is especially true if you're working on screws that go into plastic posts. Self-tapping screws into plastic posts. The posts wear out very quickly. Turn it backwards till you feel it engage and drop it in. Let's actually see what the instructions say. The last step is the assembly of the switches and the front panel. The power rocker mounts at the extreme right. The paddle switches are provided in both 2-position and center off. The 2-position switches are used for address data. 16 over here. That's IC insertion. So they really have us get the switches inserted, get them squared up, and then solder. When the board is, the entire row has been spaced accurately, the board should be turned over and the center switch should be soldered in. So there's natural bowing. The PC board material itself in that sheet metal, nothing's perfectly flat. And you want the two assemblies hooked together to be as square and flat to each other as you can. And that's what they're saying here. Is I'm going to grab a blue one because it'd be the right location for this. With a blue switch in place, they recommend getting everything nice and parallel, then soldering that switch to help hold things in place. That's what that's commenting on. Oh, ribbon cable. I'm going to start with the power switch. There are markings on the switches. I'm going to rotate those markings so they all face the same way. The markings are different on the two sides. I really struggle with this step personally. It's not difficult, that's just me. And with the smaller nut driver, I can get onto that screw, hopefully get square to the sheet metal, and cut a fresh set of threads. Now, right now, the switch is not down into the solder holes on the PC board, but they're dropped in. I felt that tighten up. It's still a little bit loose. I can move it around. And I believe the pattern is, yeah, red, blue, as we work across. I'm going to get a second one in place. I need to put that nut driver where I can't keep grabbing the wrong one. I did this with different tools than the nut drivers the first few times, and I can say it was difficult. So why aren't you, there you're lined up. Again, you don't need to torque these highly down. And they do comment here, get them snug down, but so you can move them to get them aligned nice and square. Really struggle trying to use different tools than nut drivers. I tried to use a small socket set. None of those things worked well. They were really fiddly, and you honestly cannot do it with a flat blade screwdriver with any accuracy and not damage things. Again, these are momentary contact. They return to center. Now, because these are the first time these are being turned in, I'm not turning the screw backwards. There's no threads to catch until I've inserted the screw the first time. And you can see this here is coming together quite well. Hopefully I didn't just curse myself by saying that. It looks like I did, because I cannot get that screw started. It is being stubborn. If I could find my magnetizer, I would attempt to magnetize the nut driver here. Yeah, I have cursed myself. This one is being extremely fiddly. And again, try to keep them square. That one isn't perfectly square, but it's close. You don't want to drive them in at a severe angle. They won't grip well. And there should be one more blue one out here to the end. Wow. That's what I get for saying it was going easily. I really do need the switch to drop down into the solder holes. I can see that one's not square. They overall look pretty square to me. I'm just looking to get the spacing a little more even between them. And it's a mechanical thing. It's never going to be perfect. Again, with these, if you have to back them out, do the backwards turn to catch the set of threads we just cut and run it back in. A little bit more torque here to hold these in place. Check them again for square. That looks pretty good to me. It's not perfect, but it never is. So I'm going to go ahead and solder these, but first let's talk about the fact that these switches are not all the way in. The pins are floating in the holes. This probably isn't going to show up or focus, but the bottom of the red plastic here on the switch is not up tight against the circuit board. It's being held up off the board by the support bracket. And that results in the pins basically floating here in the holes. And that's correct. That's how it should go together. They look pretty square to me. I can figure out a way to keep the board from rocking around here and not knock the screws off flying. Excuse me. We'll get some solder here. get the soldering glasses. The most important part is being able to see, at least it is for me. That's a toggle. He was sitting there by himself. Worried for a minute I'd screwed the switches up. I've got a larger tip here in the soldering pencil, just because this is a larger amount of material to be heated. You want to get a nice fillet there on the solder. I'm only going to solder one pin at a time on each switch. I'll talk about why I'm doing one pin at a time in a second. I probably should have checked this for gap between the board and the switch bracket before I committed solder on those. The gap looks okay to me. There's a little bit of flex in it, but it's nothing bad. By soldering one pin at a time, because that metal pin runs inside of the switch, one pin and then I move on to the next switch, it gives that first switch time to cool down internally. If I hit all three in a row, all three of the pins are throwing heat into the inside of the switch, and you just get a larger amount of heat build up in the switch. So, see, I prefer to walk across and hit one switch at a time. Doesn't need huge amounts of dwell time. The mechanical stress of actuating the switches should be taken up by the switch bracket. The solder is not what's meant to support the switch here. You get a more reliable mechanical connection with the bracket, and by not putting that stress as you toggle the switches into the solder joints should do a better job of not cracking. So I don't know why, but I'm obsessing here. I'm going to flip it over and look again. They look fine. Again, I've given a little bit of time there for things to cool off. See, I'm getting a lot of oxide buildup on the tip, even though the pins on the switch are gold. And even though they're gold, there's still oxide that's collected and it's being cleaned off by the flux and it ends up on the tip. I've mentioned this in other videos. That really does finish those 6 switches. Power. Things look square. I'm happy with that. I am going to come back and just try to put a little bit more torque on these screws. It doesn't need to be a lot. I had them pretty tight before. I don't want to do so much movement that it attempts to move the switch, because that will put stress into the solder joints, and these all feel fine. So before I got to this point, I did put the board into an S100 machine. So I could check the 5-volt regulator was working, which it was. I had proper 5 volts. And with a machine, that you can get the board into, the CP-A will mount. There's an MPU-A card, the processor card for the cable to plug into. It's in a proper backplane, an EXP22, in this case, backplane and a power supply. I was able to power it up and use a pair of tweezers to kind of poke around over here just to make sure the basic functionality was there. I'm going to go off and do that again because I can do a little bit more testing here with it in this state. I can't test any of the address data inputs, but I can test things like reset, run stop, deposit next, examine next. I can at least see on some of these that the addresses increment even if I can't change data. So it just gives me a little more faith that the build has worked. As you can see, if you had to work on this IC down under here, it would be very difficult with the switches in place. While we're talking about that, I'll give you another bit of information here. This is that original panel we keep pulling out and discussing here. You may notice none of these switches are soldered in. The pads on this board are really delicate, and when you're unsoldering these switches, it's really easy to damage the pads or completely remove the pad. You really don't want to be putting the switches on and off. Don't do it if you absolutely don't have to. Like I say, it's really easy to damage this. In this layout, we chose to do a couple of things. The opening for the switch pins is a little larger, and there's a little more copper on the front and back to make it a little easier to remove a switch if you have to. But again, you really want to resist removing switches unless you absolutely have to remove them. So I'm going to go plug this in. Because I have a machine I can plug it into. You may not have a machine at this point without a known good MPU-A CPU card, known good backplane, known good power supply. It becomes a chicken and an egg problem. This doesn't seem to work, but is it the card, the backplane, the MPU, is there a power supply issue, etc.? I have a stable system I can test in. You most likely won't if you're building your first IMSAI S100 machine kit. It's interesting bringing that full system up when you really can't test the CP-A or the MPU without both the CP-A and an MPU that are known working. But I'll go pop this in, see what I can make it do, and I'll be back in a moment. As always, I appreciate you watching the video. Like, subscription's always nice, comments, feedback, try to read them all. In the next video, I think we're going to actually do some testing with the control panel switches mounted. So I hope to see you in that video.